What does the future look like in practice? When we compare China and the United States today, on this day of February 8th, 2026, we see two different answers to this question. This essay will explore these differences by looking at the tangible elements of modern life. We will examine the cities people live, in transportation, people use the buildings, people see technology, people interact with every day. The focus is not on abstract policy, but on lived experience. The goal is a clear, simple comparison using facts and examples to show how futuristic each nation feels on the ground. The journey takes us through the gleaming new cities of China, 5G artificial intelligence managing traffic paying for groceries, high-speed rail networks in China, bridges and roads in both nations, different strategies for building smart cities, rapid, large-scale rollout in one country more deliberate, localized steps in the other. A picture emerges of two unique approaches to innovation and progress, neutral and factual. Short sentences and plain words make this easy to follow. Real-world examples show how trends affect ordinary people. City brain changing a commute in China. A worn bridge changing a U.S. driver's daily route. These practical questions are central. A detailed snapshot of the present helps us see the future unfolding. A balanced summary of strengths and differences between China and the U.S., practical impacts of development models on citizens. Streets, trains, daily technology, more than steel and circuits. Values, priorities, and ambitions shaping both nations. Not declaring a winner, understanding different futures built right now, brick by brick and bite by bite, in two very different ways. China's urban landscape is defined by rapid and large-scale construction. Cities like Beijing, Shanghai, Shenzhen cities are being systematically reimagined with new master plans. Entirely new urban centers are being built from the ground up. Xiong'an New Area, modern skyscrapers, expansive shopping malls, meticulously planned public parks. A key technology driving this transformation is building information modeling. By 2025, its adoption among Chinese construction firms had reached 74.1%. Montage of rapid construction and changing skylines in China. New construction happens, but a substantial portion goes to maintenance and repair, crews fixing roads, bridges, and transit systems. The United States has committed significant funds, but it's spread out over years and states. On the ground, old and new coexist in a complex balance. China's approach: massive, centralized investment in creating new assets. Trillions funneled into rapid urban transformation in short time frames. The United States, a more decentralized, incremental approach focused on legacy safety. For the average person, urban life feels different between the two countries. In a major Chinese city, brand new buildings, wide roads, recently completed public works. In an American city, historic architecture, modern additions, visible signs of infrastructure needing updating. The focus on new versus old is a fundamental difference in the urban experience today. Final comparison: futuristic Shenzhen skyline versus older New York skyline with cranes. In many Chinese cities, the streets themselves have become part of a larger digital network. Smart lampposts are a common example of this trend. These are not just for lighting. They are integrated hubs. Traffic light sensors, cameras. These devices work together to gather real-time data, traffic flow, air pollution levels. In the Xiong'an New Area, for instance, the city has developed 153 kilometers of these digital roads. The data lets an intelligent system automatically adjust traffic signal timing, minimizing red light stops, easing congestion. This creates a more fluid and responsive urban environment. The sensor network goes beyond traffic management. Smart systems can identify a wide range of municipal issues automatically. In Xiong'an, over 1,000 AI-equipped cameras monitor roads' neighborhoods. The cameras are programmed to detect 19 types of problems: overflowing trash bins, illegal parking, road damage. When a problem is detected, an alert is sent directly to the city management team. That enables faster responses, more efficient maintenance, and cleaner, more orderly public spaces. In the United States, adoption is smaller and more fragmented. Some American cities run pilot programs with smart streetlights or traffic sensors. Governance is decentralized across city, county, and state levels, which makes unified rollouts harder. Different private companies compete, creating a patchwork of systems. So the smart city experience can vary a lot from town to town. The core difference is scale and integration. China implements systems citywide under a centralized plan, with streets monitored and managed by a central brain. The US takes a cautious, localized approach, where individual communities decide if and how to adopt the tools. Both countries use cameras and sensors, but speed of deployment and level of integration are very different, producing two distinct street-level experiences for their citizens. China has made the construction of a comprehensive 5G network a national priority, resulting in the world's most extensive 5G system. By 2025, the country had built over 4.39 million 5G base stations, which accounted for more than 60% of the global total. This massive infrastructure push has led to a remarkable user penetration rate. Around 75% of the population has access to 5G services. Coverage is not limited to major urban centers. It extends to many rural areas as well. This has created a default environment where high-speed, low-latency wireless access is the norm, enabling a wide range of advanced digital services. This powerful 5G network is not just for personal use. It's a cornerstone of China's industrial upgrade strategy. Many industries are leveraging the technology to improve efficiency and automation. Private 5G networks are being deployed in automated ports. Private 5G networks are being deployed in smart factories. Private 5G networks are being deployed in massive logistics hubs. This allows for the seamless operation of robots. It enables autonomous vehicles and other connected machinery. The low latency of 5G is critical for these applications. It allows for real-time control and coordination, leading to safer and more productive industrial environments. It's a key enabler of the country's push towards smart manufacturing. The situation in the United States is different. While the United States is also rolling out 5G, the process is more fragmented and uneven. The network is built and managed by several competing private telecommunications companies. That competition can lead to innovation, but it also results in significant variations in coverage and quality depending on where you are. Densely populated urban areas generally have good 5G access. Coverage can be sparse or non-existent in many rural and less populated regions. This digital divide means the experience of wireless connectivity is not uniform across the country. For the average person, this difference in 5G deployment has practical consequences. In a typical Chinese city, a person can generally expect a stable, high-speed connection almost everywhere they go, streaming high-definition video, engaging in lag-free video calls, using augmented reality apps smoothly and reliably. In the United States, access to the full potential of 5G is more dependent on location and service provider. The dream of ubiquitous, high-speed connectivity is closer to reality on a national scale in China due to its centralized and rapid infrastructure rollout. In China, artificial intelligence is not a distant concept. It is an integrated part of managing cities and daily life. A prime example is the City Brain initiative. These are sophisticated AI systems designed to improve urban management. On March 31, 2025, China launched City Brain 3.0. It is based on the powerful DeepSeek R1 AI model. The system improves city patrolling. It optimizes traffic management, all by analyzing vast amounts of data in real time. It also integrates with critical infrastructure, the smart grid for electricity, sponge city designs for flood prevention, together creating a holistic, intelligent management system for the entire urban environment. This AI use extends to critical national infrastructure, most notably the high-speed rail network. China employs a centralized AI system to monitor 45,000 kilometers of high-speed railway lines. It processes a constant stream of real-time sensor data from across the country. The system can detect potential maintenance issues with up to 95% accuracy, and it can alert maintenance teams within 40 minutes. The proactive approach has had a remarkable impact on safety and efficiency. In the past year, minor track faults decreased by 80%. No major warnings requiring trains to slow down were issued. In daily life, this integration of AI is felt in many ways. Mobile applications for navigation, food delivery apps, ride-hailing services. Facial recognition is often used for payments and access control, streamlining transactions and security. City AI systems, like cameras that detect overflowing trash bins, work in the background. Shanghai is taking this further with a quantum space-time intelligent city framework. It uses digital twin technology to simulate governance decisions before implementation, a concept moved from science fiction to daily reality. The United States is also a global leader in AI research and development, but its application in public services and daily life is often more fragmented. Many American tech companies are at the forefront of AI, but city management efforts tend to be smaller, project by project. Public debate around data privacy and government surveillance is more pronounced, which can slow adoption of citywide camera networks or integrated digital identity systems. While Americans use AI every day through apps and online services, China has decisively invested in high-speed rail, creating the largest and most advanced network in the world. With approximately 45,000 kilometers of dedicated lines, the system connects nearly all major cities, making long-distance travel fast, affordable, and convenient for hundreds of millions of people. This network is not static. It is constantly expanding and improving. The goal for 2035 is to have a 70,000-kilometer network built on an 8 vertical, 8 horizontal backbone, creating an even more comprehensive national grid. This massive investment has fundamentally changed how people travel and connect across the vast country. The technology behind this network is also pushing boundaries. China Railway is currently testing the next-generation CR450 series high-speed train. This prototype is designed for an operating speed of 400 kilometers per hour and has already reached 420 kilometers per hour in trial runs. The safe operation of these faster services is managed by advanced digital signaling systems and AI-assisted traffic control. This combination of extensive track and cutting-edge technology makes China's high-speed rail a defining feature of its modern infrastructure, offering a glimpse into the future of ground transportation. In sharp contrast, the United States has a very limited high-speed rail network. The vast majority of long-distance travel within the country is done by airplane or car. While there are some corridors with faster train services, such as the Acela Express in the Northeast, they do not reach the speeds or scale of China's network. Plans for true high-speed rail in regions like California have faced significant delays, cost overruns, and political hurdles. The national transportation philosophy has historically prioritized the development of interstate highways and a robust air travel industry over a national passenger rail system. This divergence in transportation strategy highlights a major difference in national priorities. China has made a centralized, state-led commitment to building a futuristic rail network as a public good and a tool for economic development. China's commitment to infrastructure development staggering in its scale and speed. In 2022 alone, the country planned to invest around $2.3 trillion. This massive funneling of capital has resulted in the rapid construction of not only railways, buildings, bridges, ports, tunnels, airports. This focus extends beyond its own borders through the Belt and Road Initiative. In 2025, the BRI saw a record $128.4 billion in construction contracts, funding projects in other countries and further cementing China's role as a global builder. This strategy creates a powerful engine for economic growth. It projects an image of modern capability. The physical results of this investment are visible across the country. Gleaming new suspension bridges span vast rivers and deep gorges, connecting previously remote regions. These are not just functional structures. They are architectural marvels and symbols of national pride. Much of China's core transportation infrastructure is new, designed to the latest standards, and capable of handling high volumes of traffic. The situation in the United States presents a stark contrast. The country's infrastructure, while extensive, is much older. A major challenge is the state of its bridges. Across all 50 states, approximately 1 in 3 bridges is in need of repair. Drivers cross bridges classified as structurally deficient over 163 million times every day. While the U.S. has passed legislation to invest $1.2 trillion in infrastructure, that amount is intended to be distributed over 5 years, and is largely dedicated to repairing and upgrading existing structures rather than building new ones on a massive scale. This difference highlights 2 very different stages of national development. China is in a phase of rapid construction, building the infrastructure it needs for a modern economy. The United States is in a phase of maintenance and modernization, dealing with the legacy of infrastructure built many decades ago. China's centralized system allows it to direct enormous resources to large-scale projects quickly. In the U.S., the process is slower and more complex, involving coordination between federal, state, and local governments. Consequently, the feeling on the ground can be one of constant newness in China versus one of gradual repair in the U.S. China is pursuing the concept of the smart city with unparalleled ambition and scale. The country is home to around 500 pilot smart cities. These projects stretch beyond megacities to urban centers of all sizes. It's driven by a comprehensive top-down strategy. Shanghai is building a quantum space-time intelligent city. It's described as the most systematic smart city framework to date. The goal, a fully integrated digital ecosystem to manage the city. At the heart is the city brain, a centralized platform. It pulls data from countless sources using the Internet of Things. It uses big data. It uses AI. The result, real-time intelligent urban management. A key tool is digital twin technology. Digital twins create a complete virtual model of the city. City managers test traffic policies and construction projects in the virtual model first. That predicts impacts and avoids costly mistakes. This system has moved from theory into practice across China. In the United States, development is more bottom-up and localized. Many U.S. cities adopt smart tech, but projects are smaller and uncoordinated nationally. One city might add smart parking. Another might upgrade to energy-efficient street lighting. Projects are driven by local government priorities, or by partnerships with private tech companies, or by community input. This allows experimentation and local customization. But it presents challenges. Data privacy is a hot debate. Public surveillance is controversial. Corporate control over public services raises concerns. These debates can slow large-scale integrated systems. The result is a patchwork of smart city projects, not a unified national plan. Ultimately, China moves with a grand, centralized plan, the U.S. with cautious, decentralized experiments, reflecting different political and social systems. In a direct comparison, China today often presents a more visibly futuristic image, driven by rapid, large-scale deployment of new technology and infrastructure. Its gleaming smart cities' extensive 5G network and the world's largest high-speed rail system create a powerful impression of progress. The widespread integration of AI into urban management through concepts like the city brain, and the construction of brand new infrastructure like bridges and digital roads showcase a centralized will to build a modern nation at an unprecedented speed. For a person on the ground, this translates into an environment of constant newness and technologically streamlined services, from travel to daily transactions. The United States, by contrast, presents a different kind of modernity. Its strengths lie in its foundational role in developing many of these core technologies, its world-leading research institutions, and its dynamic private sector. However, its physical infrastructure is older, and the implementation of futuristic technologies is often more localized and slower, shaped by a decentralized political system and robust public debate over privacy and regulation. The futuristic elements are certainly present, particularly in the digital services offered by its tech giants, but they exist alongside a legacy infrastructure that requires significant maintenance and investment. If you live in a large Chinese city, your daily life is likely embedded in a highly integrated digital ecosystem. Your travel is fast on modern trains, your connectivity is seamless via 5G, and the city itself is actively managed by AI systems. This can make life feel remarkably efficient and smooth. If you live in the United States, you experience a different set of trade-offs. You may have more choices among service providers and more local control over how technology is implemented in your community. But you may also experience more variable connectivity and travel on older roads, bridges, and rail lines. Ultimately, China and the United States are not in a simple race to the same future. They are building two different versions of it. China's path is one of centralized planning, rapid execution, and large-scale integration, prioritizing collective efficiency and national development. The U.S. path is one of decentralized innovation, incremental change, and continuous public negotiation, prioritizing individual choice and local autonomy. Both approaches are shaping the daily lives of their citizens in profound ways. This short view of their cities, transport, and technology shows that the future is not a single destination, but a series of choices, and these two nations are choosing very different ways to get there.